This is a lesson on graphs of quadratic functions. This tutorial is being presented by Peter Smith. The goal of this lesson is to 1. Identify the shape of a parabola. 2. Recognize that the vertex of a parabola represents the maximum or minimum value of the function described by that parabola. 3. Identify the line of symmetry of a parabola as it relates to the vertex. 4. Understand what effect the coefficients of a, b, and c have on the graph of a standard equation of the form y equals ax squared plus bx plus c. In this lesson, what we are going to do is see what a quadratic graph looks like, and see what some of their features are. Here is the graph of a quadratic function. This curve is called a parabola. So a quadratic function will have the shape of a parabola. A parabola will either open upwards or downwards. On the parabola, we have what is called the vertex. The vertex is the highest or lowest point on the graph. Or, sometimes we say this is the minimum or maximum of the parabola. We also sometimes refer to this as the turning point. This is the point where the graph changes from a decreasing to increasing, or vice versa. Decreasing will be going down, and increasing will be going up. What we can say is that the graph of a parabola is symmetrical. If we draw a vertical line through the vertex, we get what is called the axis of symmetry, or the line of symmetry. So, this green line is the line of symmetry for this parabola. It basically shows you where the graph is symmetrical. Let us now look at the equation of a quadratic function, written in standard form. The equation of a quadratic function written in standard form is y equals ax squared plus bx plus c, where a, b, and c are constants. These are some numbers given in the equations, and a is not equal to 0. So, this is telling us that a can be a number except 0. If the a in the equation is a positive value, the graph opens upwards. So this parabola is showing the graph of a function which has a positive a value. If the a in the equation is negative, then the graph opens downwards. This graph is showing a quadratic function which has a negative a value. Then the c in the equation is called the y-intercept. This is where the curve passes on the y-axis. So, let us look at a demonstration showing how the a, b, and c affect the parabola. Please note how the graph changes as I change the values for a, b, and c. First, let us look at the effect a has on the parabola. 1. When a is positive, the parabola opens upwards and the vertex is the minimum value. So note that I am showing the values of a being positive. So as I keep the slider on the positive, the parabola stays open upwards. So you can see that all these values being displayed are positive number. Therefore the parabola stays open upwards. 2. When a is negative, the parabola opens downwards and the vertex is the maximum value. Note what's going to happen as I push the slider over to the negative. You can see that the parabola now opening downwards. So as I keep the slider on the negative, the parabola stays open downwards. 3. Changing the value of a changes the width of the opening of the parabola. So, when you change the a value, the parabola either opens wider, or it gets narrower. Note what happens as I increase or decrease the a values on both the positive and negative side. Note that when a is positive, the greater the a value, the more the parabola closes up. And when a is negative, the smaller the a value gets, the more the parabola closes up. Let us now look at the effect of the b on the parabola. Changing the value of b will move the axis of symmetry of the parabola from side to side. Note what happened as I keep changing the b value. It is being pushed side to side. Increasing the b moves the axis of symmetry in the opposite direction. Finally, you have the c in the equation. Changing the value of c changes the y-intercept. The y-intercept is the point where the graph passes on the y-axis. Note how the position of the graph on the y-axis changes as the c value changes. Okay guys, this was an introduction to the graph of a parabola. This lesson was presented by Peter Smith. Please join me in another lesson where we learn more important math topics. Let us think of education as a tool to develop our greatest abilities, because in each of us, there is a private hope and dream.